So once you have exploited a system, now you have to try to identify what can you do. And so these are things like privilege escalation and lateral movement in a network or an environment. So the post-exploitation mindset is gain access, that's your foothold, and then you want to start to identify what a real attacker would try to achieve, what they can do, where they can go, the permissions that they have, how can they gain more permissions. So if you can get a low privilege shell on one workstation, means little to whoever you're showing the report to. But if you can show that you can get into a system and then move from that low privileged account into domain administrator permissions or to a database or to the security environment or somewhere else, then that's quite a bit more critical. So privilege escalation is increasing level of access on the same host that you're on. So to go from a standard user to root, system, admin, something of that nature, or from one application's permission to the underlying OS, so breaking out of that sandbox environment. Lateral movement, on the other hand, is gaining access to a system and then using that system to gain access to other systems and then moving laterally through the network. The lateral movements is how a lot of stores, I believe it was Target, Kohl's, and Home Depot, were compromised, is the attackers got in and then made lateral movements through the network to get to the point of sale machines. A lot of times there will be a combination of privilege escalation and lateral movement as you're exploiting a particular environment. So privilege escalation in Linux, that could happen from misconfigured SUID and SGID binaries. So the user ID and the group ID. If it's not configured correctly, then it might allow a low level user to be able to do more than they might need to. There's also sudo misconfiguration. So you can set up sudo to where a user account can do whatever they need to, or you can set up sudo to where a user account can run a specific program. So a classic example is VI. You can set it up to where a user can run sudo on VI without a password. Well, once you can get into VI, then you can spawn a shell from there. There's many different ways of kind of abusing that. So that's a key thing to look out for. Cron jobs. There's if you're unfamiliar with cron jobs, they're going to be scheduled tasks which run on a set frequency, and each user typically can have their own cron as well as root, and there's also a system level cron. So a root cron job, which calls a world writable script, lets a low privilege user edit that particular script, which then can run with root permission. So kind of identifying that is important. And then there's also kernel level exploits, which typically would require patching the kernel, or software may need to be updated for that. There's also privilege escalation in Windows, and there's going to be some similarities from this, but the unquoted service paths is a unique one. Several of you have heard me rant about spaces in file names, and Windows is a big proponent of putting spaces in file names. So there's /program space files, / whatever directory with spaces in there, so on and so forth. Spaces break everything. So the reason why it can be so bad is the unquoted service path. So if you have a service and things aren't quoted around that, the first thing it will do is it will look at /program.exe. If that doesn't exist, then we'll look at /program space files /my.exe. If that doesn't exist, then it will look at /program files /myapp /service.exe. And then it will try all of those. So an attacker, knowing that, could create a file potentially at the C drive level called program.exe, which would then get run at a service level. There's also weak service permissions, where a user might be able to replace certain files that they shouldn't be able to. There's the always install elevated registry policy, which would allow a user to install MSI packages with system privileges. Typically that's not set, but it might be in a misconfigured environment. There's the stored cached credentials. So this is a big one. When you have a Windows account or a Windows system, you can use Mimikatz to dump the passwords and the accounts from memory because it's just there. And so if you have a system that an administrator has logged into and you can gain access to that, well, you can gain their credentials pretty easily. This is why Microsoft, they recommend that whenever you do anything on a domain environment, you have what's known as a privileged access workstation. And it's a workstation that is only used for certain specific tasks. That way it's very hard to get into that system and your credentials are not exposed from that system. I've also seen instances very similar to the last one where with the text editor you can elevate your privileges or permissions. There was a time once a while ago where I was evaluating some browser lockdown process for computers. And the browser lockdown service had to run with system level permissions because it needed to do specific things so that individuals could not break out of that sandbox environment there. Well, the problem is when it was running in the browser and it locked everything out. So if you tried to run any other program, or you tried to launch command prompt or registry editor or anything from the Windows interface, it would just automatically close those. However, inside of the browser, it didn't automatically close that. So I found a way that through the browser, which was running with system level permissions, I could spawn a command prompt from the browser itself, and then I had system level permissions on that particular computer. So I reported it to the company, and their response was it's behaving as expected. We did not go with that particular product. So automated privilege escalation enumeration. Again, manual enumeration is slow. As you do some of this stuff, you start to get a feel for what is working, what isn't working, various things which start to sound familiar or feel familiar. But there's also automation that can work for this. So there's the LinPs, which is for automated enumeration on Linux systems. You can use sudo-l to manually check sudo privileges. You can use the find command to look for all SUID binaries on that particular system. There's WinPs for Windows automated enumeration. And there's all sorts of other commands and everything else. So there's just a lot of different automated privilege escalation tools out there that you can use. For lateral movement, first thing you check is credential reuse, because again, if somebody used password once, they might use it elsewhere. There is also on an Active Directory environment with Windows devices, it's a lot easier to laterally move across the network if you get sufficiently high credentials for it. So if you, like I said, you get domain admin credentials, you can almost get anywhere you want without any problems. With a normal user credentials, it's a little bit harder, and so you may end up having to explore and find all the systems that that user can log into, go into those systems, and then use something like Mimikatz to dump the active users and passwords on that system to see if you can find other user accounts that then you can use to move across the environment some more. There is the pass the hash. So on Windows, NTLM authentication succeeds with just the password hash. You don't even need to crack it. So if you get the hash, you can just pass that through. Again, this hopefully is mostly patched these days, but you will come into some environments which may still allow or enable that pass the hash vulnerability. You can use a compromised host as a relay and reach internal network segments that aren't normally reachable from your particular machine. So in SSH, that's the SSH tunneling. Some of you are familiar with that. That's where you do the SSH-L, and then you can have a local port that is tunneled to a remote system. And then there's also remote service abuse, so SMB, which is just bad in general, but it's everywhere because of Microsoft. There's Windows Management, WMI. There's Windows Remote Management, or WinRM, which is bad. RDP is really, really bad. SSH is not bad, but it can be, if not implemented correctly, could be vulnerable to various attacks or stolen credentials. So realistic compromise chain. So you're getting an initial foothold. It could happen through phishing, social engineering, web app exploit. There's other exploits. So Eternal Blue could be an initial foothold, that sort of stuff. Once you're there, then you try your local privilege escalation through misconfigured services, stored credentials, any way that you can go from a user to a system or somebody higher than a user. There's also credential harvesting. So you would try to grab all credentials from a particular system to see what accounts are there. And then you would try your lateral movement. So pass the hash if it authenticates that way, or if you have other credentials, try to log into other systems, whatever the environment and again the scope would allow you to do. And then domain escalation. So if you have a machine with an active domain admin session, well, you own the entire network. That's really easy at that point. So persistence, real attackers want to survive a reboot, and there's many ways of doing it. So common ways is once you get in and you exploit a system, you set up a scheduled task or a cron job to constantly keep that exploit available to yourself. You would set up a backdoor user account. You would add in an SSH key. You would add in registry keys. You would add in whatever just to show that, yes, you can maintain that persistence there. So you only need to prove that a persistence technique works, but you don't want to leave it there. So actual attackers would want to leave that there. As a penetration tester, you want to show that it can be done and then say, okay, well, this isn't there. This is what I did to show that it could be done, and I made sure that I removed whatever persistence aspects were there. Document everything, and just document screenshots, everything. And then there's that mandatory cleanup. So whatever you do, like I said before, it's the you leave the system in the same state that you found it. You don't add new accounts. You don't and leave them behind. You don't add files and leave them behind. You don't add services or remote listeners and leave them behind. Everything that you do, you go through and you clean up afterwards. You clean up behind yourself. And so it helps when you do this to document it in the process so that you know what you have to clean up as you're unwinding everything. So defensive controls that break this chain. Least privilege everywhere. Users should not run as administrator. They should run as a non-privileged account. Administrators should not run as administrators. They should run as a non-privileged account and only elevate to administrator permissions when needed. There should also be, and it doesn't say it on this slide, but there should be like this privileged access workstation. And those are the workstations that you only log in with a specific account, and it only does certain specific things. So a domain administrator will only log into a specific machine with the domain administrator credentials, and that machine, its purpose is to administer the domain, nothing else. Not browsing the internet, not researching whatever, just administering the domain. You also want to have unique local admin passwords. So there's Microsoft Laps will randomize the local administrator password per machine. Because if it's a domain administered network, then you can set the administrator password on all the computers across the entire network easily. Also network segmentation. And this kind of goes back to those network segments and different VLANs and everything, but you want to limit who can talk to what. It's just general good practice. Credential hygiene, tiering. So like I said, domain admin should never be logged into a regular workstation. Tiered administration models prevent chained type of attacks, and the lateral movements quite a bit more. And then there's also EDR and behavioral monitoring, to where you want to have tools which will flag the LSAS memory access, any services which are created, pass a hash type authentications, things of that nature, so you can detect it. So if someone gets in, it gets detected and reported and can start to get quarantined and triaged. So PostExploitation is what turns a foothold into a business risk narrative, and you want to document all of it. Privilege escalation raises access on the same host, and automated enumeration scripts will help with that. Lateral movement is across hosts, and you might have, and you typically would combine privilege escalation and lateral movement in whatever you're doing. You want to demonstrate the persistence, but not leave it behind. And the recommendations would be, if you can do that, recommending ways to break and prevent the lateral movement and privilege escalations.